Welcome back to Smart Operator for Forestry. In the third lesson, we will discuss how you can track the energy intensity of your machines using various methods, then develop a plan to reduce the energy intensity of these machines. Large companies budget for the loss of fuel, and smaller companies can ill afford it. Theft can be a significant drain on your financial resources. An operation's profits can be dragged down by one bad machine. There's no way to tell unless you track fuel consumption. Have site conditions changed? Rising fuel consumption can be an indicator that you need to take corrective action for your operation. It can also highlight the need to maintain a machine before its mechanical condition worsens. Mechanical fuel meters are rugged and dependable and cost up to $300 for a more expensive model. These meters can be highly accurate once calibrated according to the manufacturer's instructions. Install meters downstream of filters to ensure that debris doesn't block the meter's internal working and impair its accuracy. Digital meters are smaller and easier to install, but they don't last in extreme cold or wet applications. As an alternative, new machines display fuel consumption on the operator's instrument panel, and the original equipment manufacturer's telemetry services, if offered, allow easy fuel tracking from the comfort of the office through a web browser. Here's an example of a simple logbook for tracking fuel use. This kind of form can also be combined with payroll record keeping, which is a strong incentive for having the crew fill out the form every day. Filling out the form can provide historical data, as trying to figure out why fuel consumption has increased or decreased can be difficult to do without data to back it up. The days of service recorder use are over, as the time needed to replace the cards and analyze the data output is considerable. Although the multi-DAT data logger uses older technology, it can be brought up to date with modern add-on devices. If you have some of these data loggers in your operation, consider upgrading them with J1939 serial data links, which can read the fuel consumption data from the engine control module, or the ECM. Plus, if you install a satellite modem on the multi-DAT, you can view the data through the FPTrack web application, just like on the newer FPDAT and FPDAT2 devices. The FPDAT and FPDAT2 devices offer native support for ECM fuel consumption on the J1939 data bus, just like original equipment manufacturer telemetry. Virtually all new machines offer telemetry solutions for tracking fuel consumption as well, which is worth considering at the time of machine purchase. Keep in mind that all fuel values obtained from the ECM are estimates of fuel consumption. Reconciling and calibrating ECM fuel consumption with fuel dispensed from a metered fuel tank is essential for getting an accurate measure of a machine's fuel consumption. What can be learned from tracking fuel consumption and productivity? Well, quite a lot. Some of the figures listed here take more effort to get. The first three items are easily obtained using the methods described so far in this lesson. The last three are more difficult to obtain for all types of machines. You can get this advanced business intelligence by using log processor onboard production computers to track daily production, using map data from web-based telemetry to calculate hectares covered on a daily basis, grouping cutting unit data to track fuel use for unique or challenging terrain, separating these results from the others if you log units with different species or cutting specs to understand the cost implication of manufacturing a boutique or unusual log sort. Operations can drift from profitable to unprofitable. Recognizing this and adapting is essential. Costs change when operating conditions change. Bid accordingly. Using the methods for collecting fuel and production data discussed previously in this lesson, let's work through two examples. The first will be an example based on time. The second will be based on cutblock or area. First, we need to make a couple of assumptions. Each type of machine should operate on similar terrain. If work was different for each machine, you need to have a clear understanding of this difference to better judge the results. Hours of work need to come from a reliable source. Use engine hours if necessary, but don't use payroll hours. Better still, use productive machine hours from a device that uses a motion sensor to measure working time. The first example is based on time and spans 3 months. We see total liters and hours, which gives us liters per hour to consider. Skidder 1 worked more hours and burned less fuel. Why? Was the operator less productive or spent time idling the machine? Is Skidder 1 a more efficient machine? Feller Buncher 2 consumed more fuel. Why? Is the operator a big producer? Was the operator tasked with cutting on steeper terrain? There's a dramatic difference in fuel consumption between the processors. Is there a technical difference between the two machines? Is the high-consuming machine older and in need of repairs? There can be many reasons for differences in fuel consumption, and this knowledge can point you in the right direction for corrective action. Working from one quarter to the next, we see differences in fuel consumption. Focus on excesses. 0% to 5% is not significant, but differences greater than 10% are. In this example, Skidder 2 experienced a significant change in fuel consumption. What changed? A discussion with the operator or foreman is needed. In the second example, based on fuel consumption and productivity that occurred in one cutting unit, we have to make some assumptions. Production is evenly distributed among the machines, which is unlikely. If you can integrate production computers, particularly those found on log processors, this can be refined. If you have data from telemetry devices like FPDAT and can see on a map where each machine operated, such as with FPTrack, production could be based on the area treated, a useful refinement which can also be used to further your machine management. Using this data, we can see the energy intensity, or liters of fuel per cubic meter of wood produced. Once you start collecting this data, you will cultivate an eye for what is normal and what is not. Using energy intensity calculations for 2 or more cutting units, we can compare the differences on a percentage basis. Here is where we can gain the most knowledge about the machines and operators we manage. Here are some of the insights we can gain from this example. Block 2 clearly cost more to skid logs to roadside. Do you know why? Was the extra cost in your bid price? Chris was also less efficient. Was this according to plan? Was he tasked with operating on the more difficult ground, or was he skidding uphill? Buncher 2 experienced a dramatic increase in energy intensity. Is there a problem with the hydraulic system that could be corrected? Look for the big numbers. They'll jump out at you from the data. Start improving your operations there. In conclusion, tracking fuel use pays big dividends. You can do something about it. Fuel costs can be reduced. Measure it, react, and benefit. What is an energy efficiency program, and why do you need one? You need an energy efficiency program if you want to make the most from your hard-earned investment in people and machines. It doesn't happen by accident, and if it did, you clearly wouldn't be making as much money as you could. A formalized program spells out the elements needed for success. Many such initiatives fail due to one or more critical steps being poorly conceived and executed. This small exercise in planning will make the most of your efforts. 1. A commitment from management. Management needs to back the program coordinator with the authority to make changes. Easy to do if they're the same person, as is the case in small companies. 2. Clearly define objectives. What is to be measured and accomplished? At program startup, you may only have one objective, to track fuel consumption by machine, for example. 3. A program coordinator or champion. One person needs to be tasked with seeing the program through. 4. A team approach. Get everyone involved and make everyone responsible for at least one element of the program. Let the crew know that the program is important and their efforts are needed and appreciated. 5. Operator training. Identify gaps in skills and provide training to bring your less skilled operators up to high producer levels. 6. Follow up on results. Show the results to your employees and explain why the results matter. Group and individual discussions are needed, as some employees may need extra time to digest the meaning and importance of the message that you're trying to convey. 7. Dialogue or coaching. Coach new hires in best operating practices. Don't just hope and pray that it all works out. 8. A performance incentive program. Give employees a reason to perform better. This is a whole new topic, which we will talk about in the next slide. Motivating your operators can be a complex task. Much has been written about performance incentive programs. Done wrong, and they can demotivate your workforce. It's important not to lose sight of the goal and your audience. You need simple motivation tools that speak to your workers in a manner that they can relate to. Keep it simple. Consider providing feedback by including results with pay stubs. For less educated crew members, a one-on-one discussion is better. And better yet, if there are good results, share them with the crew as a group. Simple things like gift cards or improvised barbecue lunches can go a long way in building morale and a cooperative spirit. In this lesson, we have learned how you can better manage your fuel cost using simple fuel meters or more complex telemetry systems. We have discussed the benefits of tracking production and fuel use and how these practices can support an energy efficiency program. Remember, you can't manage what you can't measure. Join us in the next lesson, where we will cover how you can improve the operation of your machines through better maintenance and operator practices.